piecewise functions are basically functions that are made up of different pieces of lines. So this one has one piece that has the equation y equals x plus 5, and then the part that is the piecewise is the inequality tells you what x values are actually used for your points on your line. It's not the whole thing all the way across the coordinate plane. So if you kind of look at it here, x equals -3 is kind of your boundary line there. I drew it in vertically. And the point where this line stops at is the point -3, too. And then the inequality says my line contains x values less than -3, so all the points on this line are to the left of that boundary line, because that is where your x values are less than -3. The second piece is kind of similarly, it's just a section of regular linear function, but this one has the x values greater than or equal to -3. We're going to graph by hand and using Desmos on these. I want you to be able to do it both ways. So to restrict your domain and actually have the line be a part of a piecewise function, what you have to do is go in the ABC menu after you've typed your equation of your line and pick the squiggly braces and then write your inequality inside of that, which basically just restricts your x values that it graphs to that section of the coordinate plane. It won't show open or closed circles for you on the endpoints, so you kind of have to know whether or not they're open or closed, or you could screenshot it and then put it in. If you're writing the equation of a piecewise function, you start like you would any other linear function by thinking about each piece individually and thinking about your slope and y-intercept. So I'm going to do this orange piece here first. You can see it crosses the y-axis at 4, so I'll go ahead and put my y-intercept in. I'm just looking at rise over run to think about slope. It goes up 1 and right 1, so my slope is 1. Now, on my piecewise function, notation-wise, it's a squiggly brace for the whole thing, and then I don't need the y equals because it already has like g of x equals. I need to state what x values are used for my points on this line. So let's look. It kind of stops at the x value of 1, and then that point doesn't actually, it's not actually a part of your line. It's not included because it's an open circle. So the points on this line are only the points with x values that are less than 1. So that needs to be part of my piecewise function. And then for piece number 2, let's go look at this blue piece over here. If you think slope and y-intercept again, it's not extended such that you can see where it crosses the y-axis at. Let's do slope first. So I'm going down 1, right 1. My slope's -2. You could always pick 2 points and use your slope formula to get your slope as well. So a point that is on my line is the point 1, -3. So if I want my y-intercept, I could plug in that x and y value and then solve to get my y-intercept. It's not the only way to do it, but that will always work. So my y-intercept is -1. You could also think about extending this line backwards, and if it is such that it's going to cross at an obvious location, like this one would hit the y-axis at -1, you could get it that way. Now, inequality-wise, this line contains the points to the right of x values of 1, so that is for x values greater than or equal to 1 on my inequality, because this is a closed circle, and this line does include the point with the x value of 1. We're going to use our piecewise function to evaluate some function values. So we're going to do with the graph and the equation that we wrote both. So g of 1 means find the output when your x value is 1. So if I'm looking for the point with the x value of 1, that's the point down below on the blue line, not the open circle up above. That point has an output value of -3. So when you plug in 1, you get out -3. If I'm going to evaluate g of -4, that means we're looking for the output when our input or our x value is -4. So if I go look along the x-axis and find the point that has an x value of -4, that's the point -4, 0. So when x is -4, I'm getting an output of 0, and g of -4 is 0. We should get the same thing when we evaluate it using our equation. So if you're thinking about plugging in 1 into this piecewise function, you first have to decide whether to use the orange or the blue equation. So if you look at your inequality, 1 is not less than 1. So we're not using the orange equation. It is equal to 1, so we'll use the blue equation and plug in x value of 1. You end up with -3. If you look at -4, decide on your two inequalities there. -4 is less than 1. It's not greater than or equal to 1. So I'm going to use the orange equation and plug in -4 for x, and you get 0 out. Like I said, if you've done things correctly, you should get the same thing either way, and we did. Okay, we're going to graph some piecewise functions. I do want you to be able to graph these by hand, not just using Desmos. So we're going to graph this one. If you look at it, it has 3 pieces for your piecewise function. So how I usually graph these is one piece at a time. I usually graph the whole line and then erase the part that I don't need based on my inequality. So this one, my y-intercept's -1, my slope's 1/3. So just like I would normally, start with my y-intercept, go up 1 and right 3, and then draw in my line. Now, if this just didn't have the restriction of x values less than or equal to -3, that would be my line. But it does. So let's make sure we have the right points. So the vertical line there is kind of my boundary where x values are equal to -3. If this is less than or equal to, that means if you look at your x-axis, values that are less than or equal to -3 are on the left side. And then it is an or equal to, so I should have a closed circle on the endpoint at -3. All right, piece number 1 down. Let's do piece number 2. So if you think about this one, it's a horizontal line consisting of all the points with phi values of 2. So I could sketch in some of those points here. If I didn't have my inequality, it would go all the way across my coordinate plane. But I do, so let's think about which of those points I actually need. I'm supposed to have x values greater than -3 and less than or equal to 1. So if you think about the x values that make that inequality true, those are the ones in the middle there, between -3 and 1. I need to include the point with the x value of 1, because that one is an or equal to, and not include my point with the x value of -3. So I'm going to have an open circle at -3 and a closed circle on my point at 1. So let's fix that. And then I need to include all the points in between there, so we will connect them, points with fractional x values and all, as long as they're in between -3 and 1. All right, last piece. Erase all my mess here. This is y equals -2x for x values greater than 1. So y-intercept is 0. Start there. Slope's -2, so down to right 1. And then if you think about your x values of points to include here, you need the x values greater than 1. So I'm going to just include the points to the right of that boundary line where x is equal to 1. Make sure it's an open circle because it's a strictly greater than, and we're good to go.